My name is Jordy Vos. My goal is to make the engineering and construction industry a more sustainable and cost-effective industry by going digital. And I'm going to show you one of my key projects that I'm currently leading that really contributes to this. I'm working for Witte Vos. Witte Vos is a Dutch consultancy and engineering firm where I'm working since 6 years. And I'm currently temporarily based in our office in Singapore, where I'm setting up a digital construction team and related innovation projects. I have a background in civil engineering with a specialization in building and construction technology from Eindhoven University in the Netherlands. So as civil engineers, we are responsible for some very impressive accomplishments. For example, stunning skyscrapers, foundational infrastructure on a massive scale. But our industry, as you probably know, is also facing some challenges. We are, for example, responsible for almost 39% of the worldwide CO2 emissions. Our industry has 30% less productivity compared to other industries. But as a relatively big industry, almost 30% of the world's GDP, making a positive impact in our industry will make a very big positive impact worldwide. Going digital, digitalization and automation is a very big opportunity to improve all of this. And therefore, our integrated building information system is a very important step in this direction. So this is basically a web-based online platform to manage design and construction projects in a completely new way. We are developing this for the Building and Construction Authority in Singapore, who is responsible for almost 80% of the houses in Singapore. It is part of a larger project, which has a total contract value of almost 3 million euro. The overall goal of this platform is to avoid making mistakes and rework during construction, to better keep track of budgets and timelines, and to increase efficiency, such as the productivity and the material usage. And we do this with this platform by managing the design process and the design changes online. We log real-time information of the construction processes to speed up all the data sharing, and we connect to construction equipment of the future, such as a smart tower crane. So how does it look like in practice? We are basically loading a digital version of the building design in our platform, which we are analyzing, and we keep track of changes in this design. We also connect all kinds of information to that building design and the building components, such as the construction schedule, the prefabrication schedule, and the logistics information. And we also connect to all kinds of smart devices on the construction site, such as handheld devices, and smart equipment, which is also under development in the same project by our partners, such as a smart construction crane. We receive from all these devices a lot of information. We also interact with them, and we monitor this information and we visualize it in our platform. And in this way, we are working towards a fully integrated design and construction process that is more cost effective, and it's saving also on time and material usage and material wastage. We have now completed the first phase of this project, which took almost 3 years, which was about the development of this platform. And we are right now starting with the implementation phase, where we are using this platform for a high-rise project that is now starting in Singapore. Through this project, I learned to work across borders with people and stakeholders from all over the world with different backgrounds and different cultures. I also learned to work on multidisciplinary teams that go even beyond typical civil engineering work. Think about, for example, software development, on very innovative and disruptive projects for one of the biggest developers in Singapore. And I also learned to envision new approaches for our industry and also learned to adopt new approaches to manage these innovation projects, such as Agile. Because I learned on the way that the typical engineering and project management approaches don't work for these very innovative projects. So I hope that through the digitalization of our industry, we keep on attracting young, new and enthusiastic talent to our very exciting industry. And I also hope that because we are full of opportunities in our industry that can contribute to the fuller sustainability of our world. Thanks a lot for your time.
The fjord crossing project in Norway is pushing the boundaries for long-span bridges. It is developing bridge concepts and span lengths that has never been built before. My name is Tor Martin Lystad. I have been working with bridges in Norconsult for 8 years, and I'm currently an industrial PhD candidate Well, actually, I'm defending my thesis later this month, so please wish me luck on that. I've been fortunate to work with many amazing long-span bridges so far in my engineering career, and by looking at this, it's hard not to fall in love with these structures. The Norwegian government is planning to build a ferry-free coastal highway route along the country's west coast. And to achieve this, several wide and deep fjords needs crossing with bridges and tunnels. The fjord crossing project is developing long-span bridge technology for efficient crossing of all these fjords. And the Norwegian Public Roads Administration is managing the project consisting of two parallel processes: development through engineering consultant companies and extensive research activity. And I've been so lucky to be part of both branches through my company Norconsult and through my PhD research. Let's take a closer look at the spectacular Bjørnafjord crossing, which is a prioritized connection. The Bjørnafjord is 5 kilometers wide and is as deep as 550 meters. Now, several bridge concepts has been studied for this fjord and evaluated, and the current choice is a curved side-anchored floating bridge with a cable-stayed high bridge in the south end. The west coast of Norway is famous for its rough weather, and the bridge concepts considered in the fjord crossing project are all extremely slender, making dynamic excitation from wind and waves very important. When we are working with groundbreaking structures, new challenges can arise. This is the equation of motion for a dynamic system, or the kid in the swing, if you will. Now the kid in the swing is able to generate an increasing pendulum motion just by moving his legs. Now what he's doing is that he's shifting his center of gravity, or rather he's changing his system parameters in resonance with the pendulum motion. This is what we call parametric excitation. This is a highly nonlinear problem that can cause instability-like behavior of a system. And when developing the curved floating bridge for the Bjørnafjord crossing, parametric excitation was a concern for the stability of the project. We found a way to describe the system as a self-stabilizing problem by utilizing the quadratic viscous damping from pontoon motions. And then the problem changed from being an instability to something we could design for. And this was significant for the progress of the project. Now, I can't leave this opportunity without mentioning my PhD research. NTNU has been monitoring the wind field and dynamic motion of the Hardanger Bridge, which is Norway's longest suspension bridge. And with the current design practice, we would predict the dynamic response as a function of the mean wind velocity as a line in this plot. And then we go out and measure on the real bridge, and this is what we see. PhD project, we have developed methods that can predict the line that is eclipsing the scatter response that we measure in full scale. And we believe that our findings will significantly reduce the uncertainty in design of long-span bridges going forward. Thank you for your attention.
Hello, my name is Krzysztof Wojslaw, and today I will show you the project that I have been working on for the last 2 years, and it's called E16 Randselva Bridge. It's 634 meters long cantilever bridge with a main span of 200 meters. The bridge is situated near Oslo, and I have been working there as a head of parametric design team at Efca. During my VDC certification at Stanford University, Martin Fisher said that this bridge is a lighthouse achievement for consulting engineers. And today I will show you the 3 reasons why this project is a game changer for our industry. First of all, this project is the largest project delivered to date without drawings. We call it model-based. And as designers for centuries, we have been delivering drawings to the site. Afterwards, we changed a little bit a way of working, and we have been preparing 3D models. However, we still have been flattering the structure to the 2D representation, to the paper, and then requires that reimagining the 3D structure by all the builders. Nowadays, with the use of the newest technology, we can build directly from the 3D model. And this approach ensures that we have better quality of delivered project. We have less collisions, fewer collisions, and fewer errors. More than that, design time is reduced by skipping time-consuming drawings, for example, reinforcement drawings. And in addition to that, we have fewer questions from sites because workers can rotate 3D model and take new sections and views and for better understanding the 3D model. The second reason why this project stands out from the rest is the application of parametric design on the large scale. Almost 70% of this bridge was parametricized, which means that geometry was described by algorithm. And this approach helps with adaptation for all changes, so we can quicker adapt all the changes. Afterwards, we can create our complex geometry. As you can see on the screen, there's plenty of complicated cables at this bridge. The third reason is a collaboration. On this project, we have organized a hackathons together with integrated concurrent engineering. So hackathons are kind of meetings where developers are sitting together in the one room and are working really intensively on a script which automizes the processes of design the bridge. So we gather all the parametric design team that work together on the program. On the other side, we have integrated concurrent engineering. This method originates from NASA collaboration session on the mission program. So ICE sessions gather all decision makers, client, contractor, designers at the same place. Design works are conducted simultaneously, which makes it possible to introduce and approve changes during the one session. So this approach, connecting hackathons together with integrated concurrent engineering, helps us to find the most sustainable and optimal solution. So to sum up, new collaboration methods together with parametric design and skipping the drawings without any doubt is a future of engineering and sets standards for the whole industry. That's all for today. If you have any question, please do not hesitate and write to me.